Dozens of earthquakes hit a single volcano just west of Naples in one day, and one of them was the strongest ever measured there in the modern era. A magnitude 4.7, striking just 3 kilometers beneath the town of Pozzuoli, cracked walls, tore a chunk of building facade loose onto the cars parked below, and sent thousands of people out into the streets to spend the night away from their own homes. And here's the number that should stop you cold. Roughly 2.4 million people live within 20 kilometers of where that quake struck. Stick with me to the end of this, because by the time we're done, you'll understand why records at this particular volcano are supposed to be physically impossible to break, and why they keep breaking anyway. If you want the real science instead of the panic, hit subscribe, because on this channel we deal in facts. Now let me show you exactly what just happened and why the scientists watching it are so uneasy. It struck at 7:46 in the evening on July 31st. On the western edge of Naples, the ground snapped harder than it has at any point since scientists began keeping careful records. This was a magnitude 4.7 earthquake, and it ruptured inside the Campi Flegrei caldera at a depth of only about 3 kilometers, less than 2 miles down. Its epicenter sat near the Solfatara crater, barely 5 kilometers from the center of Pozzuoli and about 9 kilometers from downtown Naples. Italy's National Geophysics Institute, known as the INGV, pinned down the location within minutes. And then something happened that longtime watchers of this volcano say they'd essentially never seen before. The magnitude was actually revised upward from a smaller initial estimate to a final 4.7, confirmed by the Vesuvius Observatory Operations Room about half an hour after the shaking stopped. That single number is the whole story, and let me explain why. To understand why a 4.7 is such a big deal here, you have to know what came before it. The previous instrumental records at Campi Flegrei were a pair of magnitude 4.6 events in 2025. Before that, the benchmark had stood for decades, going back to the Great Crisis of 1982 to 1984, which peaked at around magnitude 4. So this quake didn't just edge past the old records, it beat all of them. In the way Italian scientists themselves are framing it, this was the strongest earthquake felt in the Campania region in roughly 40 years of continuous monitoring. And if you zoom the timeline way out, it's the strongest seismic event at this caldera since its last actual eruption, which happened all the way back in 1538. Think about that. A volcano that hasn't erupted in nearly 5 centuries just produced the hardest jolt anyone has ever recorded there, and the location makes it worse, not better. This wasn't out at sea somewhere, and it wasn't beneath some empty ridge in the middle of nowhere. The rupture happened directly beneath the most closely watched few square kilometers of volcanic ground in all of Europe. It's the exact sector, around the Solfatara and Picciarelli craters, that volcanologists have repeatedly flagged as the most likely site for any future eruption. So when the system finally broke its own record, it didn't pick a quiet corner to do it. It broke it dead center, right under the town that's built on top of it. And that town felt every bit of the shaking. Within seconds, buildings emptied across Pozzuoli, Bagnoli, and the western districts of Naples. It was a warm summer Friday evening, so people were home, and thousands of them ended up out in the streets. Many chose to stay outside through the whole night, rather than sleep under old masonry they simply no longer trust. Several people were injured, though those hurt were treated and released. Fire crews spent the evening running from call to call, dealing with falling plaster, cracked walls, and in Pozzuoli, a section of building facade that broke loose and crashed down onto the cars parked below. Footage from the area shows boulders and rubble crushing vehicles and part of a hillside giving way. Churches and the older residential blocks took the worst of the visible damage, which is exactly the pattern engineers had feared. This part of Italy is packed with tough old block and masonry construction, some of it centuries old, and much of it already worn down and fatigued by 3 straight years of repeated shaking. The disruption spread even wider than the physical damage. Power went out across several neighborhoods on the western side of Naples, places like Bagnoli, Fuorigrotta, Soccavo, and Pianura, and on the island of Procida, just offshore. The local commuter rail lines that run through and around the volcanic zone were suspended so engineers could inspect the tracks, and the metro stopped along with them. Italy's Civil Protection Department opened a crisis desk within hours, and the Civil Protection Minister personally confirmed the injuries as inspection teams began working their way through homes and churches. One more detail stood out to seismologists. This earthquake was felt across the entire city of Naples and well beyond it, reportedly as far as the province of Caserta, more than 30 kilometers from the epicenter. Residents who have lived through every single event of the past 3 years describe this one as sharper and longer than the 4.6 quakes of last year. And the instruments agree with them. But here's the thing, the record wasn't one isolated jolt. It gets worse. The 4.7 did not arrive alone. It was the peak of an intense burst of activity, making that day one of the most seismically active of the entire unrest, with dozens of earthquakes rattling the caldera. The morning had opened quietly with small events, including a little magnitude 1.7, Then, with almost no buildup to warn anyone, the 4.7 ruptured that evening. Within minutes came a 1.7, then a 1.4, then a 1.0, and the sequence just kept rolling on through the night. There were at least 10 aftershocks in the first hours alone, the strongest around magnitude 2.6, with dozens of events on the INGV's list by late evening. And the depths of those aftershocks deserve real attention. Several of them happened at less than 1 kilometer below the surface, even shallower than the record quake itself. Earthquakes that shallow hit the ground above them like a hammer strike, sharp, loud, and violent for their size, even when the magnitude looks tiny on paper. So for the people of Pozzuoli, every one of those small aftershocks landed as a bang and a shudder through buildings that had just been stress-tested by the strongest earthquake in the caldera's recorded history. There's a pattern in that sequence worth naming clearly. This was not a single main shock followed by a tidy, fading tail of aftershocks, the kind you'd see from an ordinary tectonic fault. This was a swarm, a burst of activity clustered around the big event, jumping from one small patch of crust to another. And that's exactly what an inflating volcanic system produces, when the rock above it is cracking in many places at once. The distinction matters, because swarm behavior is the fingerprint of the process that's driving all of this, and that process has a name Italians have known about for 2,000 years. But first, let's really sit with the human exposure here, because it has no parallel anywhere in Europe. The INGV's own figures for this earthquake count roughly 2.4 million people living within 20 kilometers of the epicenter. Pozzuoli, home to more than 80,000 residents, sits just 5 kilometers away. The city of Naples proper, nearly 1 million people, begins 9 kilometers out, and then town after town stacks up inside that first dozen kilometers, all of it standing on or right beside an active caldera. Italian emergency planning divides the area into zones. The official red zone, the area that would have to be completely evacuated before an eruption, holds around 500,000 people. The core of highest exposure, in and around Pozzuoli itself, holds somewhere between 80 and 100,000. These aren't abstract lines on a map. The red zone contains working ports, hospitals, schools, and rail stations, all woven through a caldera whose floor has physically lifted the town along with it. The harbor at Pozzuoli has risen so much during this unrest that the seafloor has become shallower and ferries have struggled to dock. Civil Protection's standing plan assumes it would take about 72 hours to move the red zone's population, and that assumption itself depends on the volcano giving clear, unmistakable warning signs days in advance, an assumption that some Italian scientists publicly doubt, as we'll get to shortly. Now, set all those people against what this caldera has done in its deep past. Campi Flegrei produced an absolutely colossal eruption roughly 39,000 years ago, one of the largest explosive eruptions in the history of the Mediterranean, and another enormous one around 15,000 years ago. Let me be crystal clear, because this is where fear merchants love to exaggerate. Nobody credible is forecasting anything on that scale right now, but the underlying machinery beneath those ancient eruptions and the machinery beneath this earthquake is the same system. And understanding what it's actually doing right now requires one key piece of science. Here it is. There is no plate boundary under Naples. Nothing is grinding past anything else beneath Campi Flegrei, and that one fact changes the meaning of every single earthquake there. These events are volcanic. The caldera itself is making them. The engine behind it is a phenomenon Italians call bradyseism, the slow breathing of the caldera floor. Since 2005, the ground around Pozzuoli has been rising almost continuously, and the total is now about 1.4 meters at the center of the uplift, more than 4.5 feet. Through this year, that rate has been running at roughly 15 millimeters every month, month after month after month. The driver is pressure. Hot fluids and gas, fed from a magma body sitting some 7 to 8 kilometers down, are accumulating in the shallow system and pushing the ground upward like the lid of a pot coming to a boil. The INGV's analysis of this quake tells the same story. The faulting was extensional, meaning the crust is being pulled apart as the caldera inflates, and it was computed at just 2 kilometers deep. That is not the mechanics of colliding plates. That is the mechanics of a stretching lid. As the ground inflates, the shallow crust stretches, and when that stretch exceeds the strength of the rock, it cracks. Every crack is an earthquake. That's why virtually every quake at Campi Flegrei, including this record, is shallower than about 3 kilometers. And it means each significant earthquake here is best understood not as a random jolt, but as a strength test, a live measurement of how much load the rock over this volcano can carry before it breaks, which raises the obvious question. What exactly is being tested? Between the surface, where people live in Pozzuoli, and the hot interior of the volcano sits a layer scientists call the caprock. It's a brittle lid of old, welded volcanic rock, only about 2 to 3 kilometers thick. Below it, the rock is simply too hot to snap. It bends and flows instead of breaking. That thin, brittle layer is the only part of the whole system that can make earthquakes at all, and it's also the seal that keeps the pressurized system beneath it contained. Now here's the part most people find surprising. The very thinness of that lid caps the maximum possible earthquake. The size of an earthquake is set by the area of the fault patch that ruptures, and you can only fit a limited fault inside a brittle layer that's just 2 to 3 kilometers thick. In other words, records at Campi Flegrei are supposed to be genuinely hard to break. The physics itself enforces a ceiling, and that is precisely why this event matters so much. That ceiling has now been pushed higher 4 separate times in under 3 years, from a 4.2 to a 4.4 to a 4.6, and now to a 4.7. When a system that has a built-in maximum keeps exceeding its own maximum, the system is telling you that something underneath it is changing. And the published science makes that reading very hard to dismiss. Research produced during this unrest, including laboratory work on the caldera's own rock led by the volcanologist Christopher Kilburn and his colleagues at UCL, concluded that 4 decades of stretching and heating have progressively weakened the crust above the system, leaving it with roughly a third of the strength it had back in the early 1980s. Weaker rock, carrying more stress, breaking in bigger patches, closer to the surface. Every part of that sentence points in the wrong direction, and every new record is another data point confirming the trend. So, what does one more record actually mean? Scientists watching this system see 2 defensible ways to read this earthquake, and the genuinely unsettling part is what those 2 readings have in common. The first reading is the less alarming one. Decades of uplift have compacted and locked sections of the shallow crust, so stress now builds up across larger patches before letting go. In this view, the caldera is getting stiffer in places, storing more energy per rupture, and when it finally fails, it fails bigger. The earthquakes grow not because the danger is growing, but simply because the rock is releasing its load in larger, less frequent installments. That version fits a caldera aging through a long unrest without necessarily heading toward an eruption. The second reading is simpler and less comfortable. The driving pressure from below is still increasing, and the system keeps finding new ceilings because the push keeps getting stronger. Same source, same mechanism, larger and larger releases, a trend line that hasn't bent in 20 years and shows no sign of bending now. The data we have today can't cleanly separate those 2 readings, and honest scientists say exactly that. But notice what both interpretations share. Under either one, the ground shaking gets worse before it gets better, because neither the uplift nor the energy release is slowing down, and shallow earthquakes punish buildings far beyond their magnitude. A 4.7 at 3 kilometers deep delivers far more violence to the structures directly above it than a much larger earthquake, 40 or 50 kilometers down, ever could. And remember, magnitude is logarithmic. This event released roughly 1.4 times the energy of last year's 4.6, and about twice the energy of the 4.4 events before that. Italian engineers have warned that an event in the magnitude 5 range, which this trajectory cannot rule out, could start outright collapsing the weakest of Pozzuoli's fatigued masonry. The jump from 4.7 to 5.0 sounds tiny, but in energy, it's nearly a factor of 3, and this caldera has already climbed half a magnitude unit in just 3 years. That climb isn't an impression or a vibe. It's a ladder you can draw, rung by rung. Follow the sequence. September 2023, a magnitude 4.2, the strongest of the modern unrest at the time. May 2024, a 4.4, instantly labeled the strongest in 40 years. March 2025, another 4.4. Then June 30th, 2025, a 4.6, setting a new record, followed by a second 4.6 later that same year. May of this year, another 4.4. And then this July, a 4.7. 4 record-setting or record-tying earthquakes in under 3 years, each striking the same few square kilometers of caldera floor, each one landing on buildings already cracked by the one before it. So this record is not an isolated event. It's the newest and highest rung on a ladder this volcano has been steadily climbing since 2023. The historical comparison sharpens it even further. The last great bradyseism crisis, from 1982 to 1984, lifted the ground about 1.8 meters and terrified the entire region. The Italian state ultimately moved roughly 40,000 people out of Pozzuoli's old center, and parts of the town stood half abandoned for years afterward. Yet that crisis, for all the fear it caused, topped out at around magnitude 4. The current unrest has now exceeded the worst shaking of the 1980s by half a magnitude unit, on crust that the published research says is only about a third as strong as it was back then. And unlike the 80s crisis, which rose and then subsided within about 3 years, this one has been building for more than 20. It's slower, longer, and it raises its ceiling a little higher every time it tests itself. But there is one genuinely reassuring fact in that history, and it deserves equal airtime, because balance matters. The 1982 crisis ended without an eruption. The system pressurized, cracked, terrified everyone, and then it resealed. 2 years of raw fear resolved into decades of quiet. That precedent is the single strongest argument that record earthquakes, all by themselves, do not necessarily mean magma is on its way. But the 80s crisis is also exactly why today's scientists watch the system so intently, because it proved the caldera can walk right up to the edge of everyone's nerves and then hold there. And that means the question that actually decides what happens next isn't the magnitude at all. It's whether anything else in the monitoring data has started to move. And that brings us to the most contentious part of this whole story, the alert level. Campi Flegrei has sat at yellow, level 2 on a 4-step scale since 2012. It was yellow when the 4.2 struck in 2023. It was yellow through the 4.4 of 2024, yellow through both 4.6 of 2025, and as of this record-breaking 4.7, it is still yellow. No change was announced. The official position is that this event, record or not, remains consistent with the ongoing unrest, pressurized fluids cracking old rock, rather than magma on the move. And to be fair to the officials, that position is grounded in real science. The alert framework is built on multiple parameters, not just magnitude. It watches the depth distribution of the earthquakes, the uplift rate, and the chemistry of the gas pouring out of the fumaroles. The signals that would genuinely indicate escalation are specific ones: earthquakes migrating downward as if tracking rising magma, a certain kind of continuous tremor, uplift accelerating well past its current rate, or a step change in the magmatic fraction of those fumarole gases. As of now, none of those thresholds have been reported crossed. On the framework's own terms, yellow is defensible. But a growing group of Italian scientists argues that the framework itself is the problem, and they've gotten louder with every record. Their case runs like this. The alert system is calibrated to detect magmatic escalation, but the two hazards most likely to hurt people in the near term have no formal trigger anywhere in it. The first is exactly what keeps happening. Repeated shallow shaking, slowly demolishing a fragile building stock, a few injuries at a time. The second is a phreatic explosion, a steam-driven blast from the overpressured hydrothermal system that requires no magma at the surface at all, can happen essentially without useful warning, and would be lethal within its radius, in an area this densely packed with people. Several prominent researchers have said publicly, speaking as individuals rather than for their institutions, that they would already be moving the most exposed residents of the Pozzuoli area, because a warning system tuned to detect magma might stay calmly yellow right up until the moment one of those non-magmatic hazards arrives. And this tension feeds a viral claim I want to address and dismiss quickly, that the authorities secretly know an eruption is imminent and are covering it up. The data simply do not support that. The ENGV publishes its monitoring bulletins every single week for anyone to read. The deformation and gas numbers are public, and none of them shifted into a pre-eruption configuration with this quake. The honest concern here is not a cover-up. It's a gap between what the alert level measures and what the residents of Pozzuoli are physically living through every day. And a record-breaking earthquake with the alert unchanged is the sharpest illustration of that gap yet. So what should you actually watch for in the days and weeks ahead? The watch list is clear, and it starts right underfoot. Watch the aftershock sequence. If the swarm around this event decays over the coming days, this record will settle into the same uneasy pattern as the last four. But if the caldera instead produces another event in the mid-4 range or higher within a short window, that would mark a further acceleration, and the pressure on the authorities to reconsider the alert level would become intense. Watch the depths too. Earthquakes staying shallow within the top 3 kilometers is the normal hydrothermal pattern. Quakes stepping downward would be a very different and far more serious signal. Beyond the seismology, 3 numbers will tell the real story. The uplift rate is the master variable, and sustained acceleration would change every calculation. The fumarole chemistry is essentially the volcano's blood test, and a rising magmatic fraction in those gases is one of the earliest reliable warnings the system can give. And the building inspections now underway across Pozzuoli and western Naples will determine how many structures enter the next earthquake already compromised, because on the current trend, there will be a next one. The record set this July will stand until the volcano breaks it, and nothing in 20 years of data suggests it has stopped trying. The strongest earthquake in Campi Flegrei's instrumental history is now also the clearest measurement yet of a system that is still loading. And the honest summary is the one the scientists themselves keep repeating. This ends with the shaking getting worse before it gets better. My thoughts are genuinely with the people of Pozzuoli tonight, living rung by rung up a ladder they never chose to climb. If this breakdown helped you understand what's really happening beneath Naples instead of just adding to the noise, do me a favor and hit that like button, because it truly helps more people find accurate information during a scary event like this. Drop a comment with your thoughts, especially if you have family in the region, and subscribe with notifications on, because we will be tracking the aftershocks, the uplift, and the alert level debate as they develop. When this caldera moves again, you'll hear about it here first. This is W for weather, where we follow the real science of our restless planet. Stay safe, and I'll see you in the next one.